I'll just
Having this conference on the moon, that would be a real kicker. 1/10 Earth's gravity. Imagine that. I
That'd
don't
be
know.
fun to have a gymnastics meet up there.
Oh yeah. Imagine going swimming in 1/10 gravity.
Oh yeah, amazing. I loved Voyager, I think it was called. There was a movie, this guy where they lost their gravity and the swimming pool, the water started coming up out of the swimming pool and was
Star Trek.
drowning this woman.
That's
Uh,
Star
real
Trek.
good look, real nice looking gal too.
The
But
episodes of Star Trek where that happened, and the water in the shower starts to like float up,
yeah, yeah.
and then they
Well,
go to engineering to figure out where the problem is.
yeah, well, I love thinking about that. I love doing those mind experiments. I love watching the guys on this on the space lab, wringing water around a wash rag or spinning a tea bag up there on the space station, watching where the water, how it accumulates around the axis, and of course, all the heavy particles go to the outside like a cyclotron. And part of my experiment is using that system, the center fling. But it's interesting to me if you trap the water center fling and it's inside a torus vessel, and all of a sudden you make the torus vessel disappear. Well, is it going to go center fling, keep going out like an explosion, or does it's going to go perpendicular? So like if it was a torus vessel and you pulled the plug on it, and it's like draining down a bathtub. So is there going to be is that getting around the Newton's third law? Think about it.
I don't know.
So my idea is like I'm using pseudo forces to combat pseudo forces because according to Hossenfelder, I think, Sabine, Jeremy, I've heard him mention her. I've got a video of her on my website, and I got a video of 60 symbols, I think, or 60 something symbols from the UK, talking about Einstein's equivalence principle. So I put those two together basically to come up with some of my design. And anyway, I'm trying to make my website sort of like a little treasure hunt. So I'm putting hints on there, what I'm designing and what I'm coming up with. And if I'm getting some people involved here in Roswell, Robert Goddard built the first rocket engines here in Roswell and tested them. And in our museum here in Roswell, we actually have his entire shop in that museum. It's fascinating. I go over there all the time. I look at that old equipment, and it's like during the horse and buggy days. But anyway, thanks again for letting me talk. I'll shut up now.
I actually once spoke to some guy from Roswell. He was highly autistic. I'm trying to remember his name. He recommended that I mix mercury and barium titanate together. I'm trying to remember who he was. He was basically this. You might know him. Just trying to find his name right now. I'll get back to you in a moment.
Yeah, I don't do mercury. Well, I've looked at different liquids. Metal liquid would definitely be best for my situation. And I've watched some MHD videos on YouTube, and they have this Serlio 44 or 144 or something like that. It's not mercury. And they've got a couple of different. I found a place where I can buy liquid metal that's liquid at like 118 degrees. And so I'm thinking maybe something like that. But to actually prove my prototype, I'm just going to use water and baby oil because the density of baby oil is like a lot. It's like an ocean in a bottle. You put ocean in a bottle and you watch the densities, the different densities. So I'm gonna make a prop with this ocean in a bottle. Maybe in a couple of weeks, I'm heading into Texas, so I'm going down to see if, a friend of mine's coming in from Alaska, and we're going to go across Texas. And it seems like Texas is the happening place now. Like Elon Musk has moved to Austin, and a couple other people. I mean, there's some big players going to Texas. I don't know exactly why. I guess close to Boca Chica and Houston, but
Midway, Texas has wasn't Tachyon, it was the other the one with Brandenburg and Murad. Uh, that aerospace company just opened up in Midway, Texas. Paul Price is the guy from Roswell, who I spoke to him way back in 2018, and he had some some crazy theories. He never really tried any of these experiments, but I don't know if you know him. If Roswell's a small town, he said he grew up there. Paul
yeah.
Price.
Well, I grew up in Carlsbad, and then we moved around. My dad moved around a lot, so I've only been in Roswell a couple of years now, but I've been making some good friends. I talked to the mayor of Roswell. He's actually a rocket scientist. He says that's old stuff that he knew years ago. That now that he's a politician, he just does his mayor stuff. And then I've talked to a couple of guys on the city council, that kind of thing, and. I tried to get this one guy involved with me to help me find a place, because I'd like to do a maker shop to try and make some of these prototypes. I'm not a maker. I'm more of an artist type, but I do have a high aptitude for science for some reason. When they tested me way back in the day, you guys are all like younger than my children, but I know I look pretty young, don't I? But I use David Sinclair's NMN, and it's making me younger. But anyway, I want to make some of the stuff, and I'd like you guys to see it. And I was hoping that I could get Falcon Space to do it. It's not really very difficult, and it just uses Einstein's pseudo idea of what gravity is. He says gravity's not a force. He says it's just a curvature of space. And so I thought, well, if you curve liquid through a small area patch of time space, and it's putting those forces on it, it makes sense. It makes sense to me.
What shape are you spinning the liquid in? Is it straight
Well,
circle or?
Yeah, I'm glad you asked, because I coined a new phrase, because I like to do fun stuff. So I'm calling it a Roswellian. The geometric shape of a Roswellian, it would take 4 Roswellians to actually to build this prototype. So a Roswellian basically is a flying saucer shape. And the reason I like the flying saucer shape, because in an angular system, most of the mass is around the axle. So the moment of inertia is a lot less, because there's not as much mass out at the edges. But when I pop the cork on the thing, in my certain construct, I don't want to give it all away, but it's like I pull the plug on the drain of the bathtub and it drains out.
We can't build it if you don't give it away.
Yeah, I'm not going to give it away, but if you want to do the non-disclosure thing, I have on my website, and then I'll share with anybody.
Yeah. Don't give it away if you're not comfortable with it. Don't do that. Just hang on to your key pieces. That keeps us all out of trouble.
Like I said, man, I'm easygoing. I wouldn't sue anybody, but you know what? I want to get this thing built. I'm not going to live forever, and I am starting to get a lot of I would say I'm getting some gravity with it now.
Yeah. Well, no, keep going on your end then. Yeah.
Okay.
Mark is juggling like 20 projects as it is. So
I know you guys.
Really Jeremiah who takes up most of the slack. I mean, he's been doing most of everything. I'm concentrating on the big ones, but we are looking to do some spinning mercury or spinning heavy liquids, and I'm all ears for whatever shape everyone thinks. Right now, Jeremiah showed me a patent that was looking to do it in a D shape, which I was kind of interested in, or a half circle. because you do the full circle, I don't see any reason why that would do anything.
I've got some half circle drawings. Mainly, you want to change the center of gravity. I was on one of your things and talking to a guy from Boeing who did the reaction wheels. And my question was about the center of gravity. To me, it's about the center of gravity. Is it dynamic? Can you move it? Can you rotate around it? Can you move the center of gravity in your craft and then rotate around it fast enough? If you can do it fast enough, you can actually make, you could escape Earth's gravity pretty easily. Like I said, you might be dizzy as heck unless you figure out how to make the passenger compartment not rotate with the tumble with the ship. So, and I have that on my website. I think you get a good idea of what I'm working at if you took a look at some of the videos there. And somebody might, it's first to file, and with the patent office, I've done a lot of study on that. So if somebody builds it, fine. I'm retired anyway. But I'm just having fun, and this stuff is just a lot of fun to me. So anyway, I'll shut up now.
I'm planning a trip actually out to Roswell here in the next couple of months. I'm hoping to fly out to Phoenix and visit with Michael Schratt and he's got a warehouse full of interesting research and files and stuff. And then we were gonna maybe go for a trip out to Los Alamos, visit Los Alamos, and then come down to Roswell, maybe stop at Wade's Bar, and then spend a day in Roswell. Maybe go to the airport. We're gonna stop in Corona, visit the crash site, and then maybe hit the actual the Hangar 84. I guess there's a tour that takes you through all this stuff too. So I'm trying to look into it right now.
That's nice. That's nice, man. I've got a house. I'm here by myself. I got 3-bedroom home. So, you're welcome to swing by, give me a call. I can meet you at some place and we could hoist a few or just do whatever. I'd like to.
Yeah, that's good to know, man. We should definitely make contact because I'm looking for more contacts out that way. Anyone between Phoenix, Los Alamos, and that's kind of like my route I'm planning right now. Fly out to Phoenix. I might fly. I was thinking about flying out to Las Vegas and starting it there, but I'm not sure if that's worth it or not at this point.
Well,
but,
my motto: if it isn't fun, I don't do it. So that sounds really cool.
Yeah, we want to film the whole thing and post it as part of a UFO road trip. Like
I have a video company. Well, I actually have all my equipment still. I produced a television show for 4.5 years, Christian television show with multicams, and I love to do videos and editing. I haven't been doing it lately because I got into this writer's block with doing my patent and doing my claims, and like that guy, like Ron said, it's a lot of paperwork to do an SBIR.
That's cool how you're waiting for Corona to be over to fly out to Corona.
Right.
You're not going to fly out to Corona. You're going to have to drive.
I'm going to drive to Corona. There's no flying there.
Yeah.
Yeah, he's going to land in Phoenix and drive to Corona.
Well, the desert's beautiful, and at night, bring some binoculars and look at the constellations. There's not a lot of light pollution. It's beautiful.
I want to bring my power motor out there and fly the canyons.
All right. I got a couple of Harleys and a couple of dirt bikes. I can't drive them all.
We'll see if you can keep up with me.
Cool. Yeah. Yeah, come out. I'll try to hook you up with something if you want to.
Yeah, that's awesome. I definitely I'll have to shoot you an email or shoot me a private chat right now, and let's connect through email.
Okay, will do.
If anyone wants to come out to the lab here in Hawthorne, New Jersey, we do have a guest house with a couple bedrooms and a couple extra beds, so you can come check out the lab. We're open to all, and don't be shy.
No sleeping on the beanbag?
No more sleeping on the beanbag. We got some serious beds set up here.
Right on.
That beanbag's not so bad though. You know, if you were like a foot shorter,
Tall people problems.
tall people problems, right? Yeah, but we have normal beds downstairs, and yeah, we're all set up right now. Lately, I've been sleeping on this couch. It's so comfortable. I know Jeremiah plans on coming out here next month. He's got a couple stuff to deal with, and we got this 3D printer. Jeremy, you said you got a 3D printer too, right?
I mean, I have one, a small one right here. It's just a small one. I'm trying to work on getting some of these molds. What I want to do is I want to start 3D printing UFOs, like little flying saucers, just to start with. They will give us something I can sell. We need some merchandise for the website, and it will give us something we could sell. And I'm working on like, I gotta check with Mark McCandlish and see if he owns rights to that ARV flux liner, or if we could just print those and sell those. Because I'd like to get 3 craft going. I'd like to get the flux liner. I'd like to get the TR3B, and I'd like to get the
alien scientist logo on the side of it. I can help you out with the STL file. I'm pretty good at that stuff. And Tom Schomburn, you know, Professor X from the lab, he's a genius whiz with G code and all that stuff.
Shouldn't be too hard. We have a lot of 3D models and other programs already and stuff. And like Michael Schratt, he's already a 3D guy, graphics guy, and he's done number of drawings. So it shouldn't be too hard to like get these things going.
Your logo attached to the side of it, so it's something unique. You don't want to just send out, you know,
Yeah, we want something awesome, something that makes it authentic and like makes it like a collector's item kind of thing.
Limited edition.
So, yeah, something cooler than the what was the doll that TTSA was selling? It was some stupid. I forget. I was laughing about it.
Oh, we still have the keychains from Alien Con. We got lots of those left.
Right on.
The biggest pain is actually making up the labels to ship them out, though.
Yeah, all that stuff. I mean, yeah, that would be. But anyways, yeah, printing them and actually getting them out and everything, and then what do we charge for them? I got to figure out the different colors and what you could do, and that would be cool though, because I want to start with just 3D printing small model UFOs to sell, but eventually we want to get like 3D metal printers and diamond printers and print real full size craft. That's
eventually the goal. Right now I got a 3D printer coming in we're super excited for. Dijon Korovic, the guy from the UK, recommended this company, and they got lots of features that I haven't seen on any other 3D printer, including the ability to print down to 10 microns accuracy, and it's a freaking like foot cube print size. So you can make some really nice high quality prints off this printer. It has a vanadium print head, and to get the print off the base, they have the base attached. It's basically a piece of spring steel that is magnetized down to the base, and when the print is finished, you're able to pull that base off and just twist it a little bit, and your print pops right off. You don't have to sit there with razors trying to get it off your Kapton.
I had an idea for you, Jeremy, too. This idea with the ocean in a disc idea, that would go. I think that might be a little bit cool. You could 3D print it and then just put a clear piece of plexiglass on it, drill a little hole and fill it halfway full of water and put some blue coloring in it. I have some, but anyway, and then
no,
you have to do the rest of it with baby oil, and then you could have a little disc with ocean in it, and then if you spin the disc, it'll make that blue band all the way around that disc. And
now we're talking, man. Yes.
And then it's like the bottom of the ocean is the outside of the disc where the circumference is. So it's like pulling the plug on the ocean. So where's Newton's third law? When you let gravity is a one-way trip. So when you pull that plug on your bathtub, it just goes down down the pipe, man. There's no backwards action. And so Einstein said that, when you're in constant, going around in a circle, you're in a constant acceleration. And his equivalence principle says there's no difference between that and gravity. They're both pseudo forces.
Yeah, I definitely think it's a much better idea than here. I have the thing we found on TTSA. This is on To the Stars Media. You can get the Boomer talking plush. It's like this guy drinking a beer, driving a skateboard. It's like a doll. No, it's $37 for that. Man, we could do better. We can do better with our little toy UFOs.
Well, I bought 4 discs. As a matter of fact, I've got one of them right here. I can show you. I bought these online, and this is 11-inch disc, and then I just bought a piece of plexiglass. Now these things are kind of expensive. I got 4 of them, so I'm going to mess around with 4 of them right now, and then I just bought some plexiglass, and I just put it on the plexiglass like that, glue it on there. So it's going to take a little bit of manual labor. So
yeah, you can use epoxy.
Yeah, or something that will bond to the plexiglass.
Yeah,
more of a gel. It might be a little messy because I don't think I can get it smooth enough to seal it on there. But I was thinking you wouldn't even have to have a clear one. If you 3D printed one. And then I don't know, it might be more expensive to do that than just to order them offline. But this cost me, I got 4 of them for about $25. But you can get cheaper ones. You can get them smaller. They don't have to be this big. And I was thinking you could make it like one of those big buttons that you put on the back of your cell phone. Have a little deal here where you could hold on to it and spin it.
So I did.
Spin it by hand.
I heard back from the liquid metal guys. I had sent off an idea to get a symbol shaped, printed from them. I wanted. They had tuning forks. They had those liquid metal tuning forks where they show them they resonate like much longer than regular tuning forks because they're made out of that. It's a metallic glass material. And so they have a metallic glass molding process, which is similar to like an injection molding process. Let me bring some stuff up on that and just on my screen. I should share a screen with you guys too, but I don't know if I can.
This is for like super fast cooling of the metal, so it doesn't have time to.
Hey, Mark, since we're in open discussion, you mind if I make you the host?
Oh, sure.
Okay. I'll be back in just a bit.
Yeah, so liquid metal technologies. What is this? Liquid metal technologies. They have the tuning fork. Yeah, this is it. Hold up, let me bring this up on my screen. So yeah, it's basically they cool it down really fast when they inject it so that it doesn't have time to harden. It doesn't have time to crystallize, and that makes it metallic glass.
Share your screen because we don't see it.
Yeah, I have it shared on the my live stream. I don't know if it will let me share both of them. Well, can you see it now?
Yep, we see it now. Yes.
Yep.
All right. So this liquid metal technologies is. I contacted this company and I asked them how much it would cost. So I got a 3D print mold, a STL file for one of these, a symbol, because they had this tuning fork video. So if you type in liquid metal technologies,
that V on the left, that's the sample that they sent me.
yeah, that little thing, that's what they send you. You can order and they send you a little free sample of this stuff. But the tuning forks, they don't have an actual sample of these. And I apparently I tried to see how much it would cost to buy the symbol. The symbol was an odd shape and everything, but they quoted it at around $20,000 for one of them. And I'm like, well, that's going to be quite expensive for, you know, even just to like get a Kickstarter started to buy one of these things, just so we could show people what a cymbal made of metallic glass sounded like. Because I'm sure everyone wants to hear as much as I want to hear what a cymbal will sound like. Now that we've seen the metallic glass tuning fork video and heard what the metallic glass tuning fork sounds like. But I haven't yet found I'll have to get an STL file together for a tuning fork or for some tuning forks. And maybe I can send that to them and see how much it would cost for one of these metallic glass tuning forks. But judging by the quote they gave me on that other piece, I don't think they're going to be cheap. It's probably going to be like, you know, like several $1,000s for one of these tuning forks.
Yes,
Yeah,
this V-shaped device that you have on the left, where it says Design Guide 5.0. That's the kind of piece that I got in the mail. I'm still looking for it. I have no idea where it went, but it's probably floating around the lab somewhere or got thrown out by accident.
So these are some pieces that they make currently for different products. I guess there's a part of inside some cell phone pieces, and there's a couple other parts that are currently made out of metallic glass. But one of the major markets they were trying to go for was golf club heads, and this whole idea of them being superior, you know, golf clubs and stuff, you know, NASA golf clubs. But apparently they weren't, you know, that great. They weren't like, you know, worth the incredible. They weren't worth $20,000. Let's put it that way. Whatever.
Wow.
The price tag is on these things currently. So yeah, we're gonna see about that. We might. I was still am interested in doing some experiments with this type of material because of the resonances involved and what it can do. But
I did find liquid metal that melts at about 118 degrees. That's supposedly not like mercury. So, but it was like $80 a kilo. So that wasn't too bad. I was thinking I might spring for that at some point.
This isn't actual liquid metal. What they're talking about here is a metal that is cooled very rapidly so that the crystalline structure doesn't form.
yeah, liquid metal is just the brand name. It's actually a metallic glass, but there are liquid metal technologies that are like gallium and
indium.
indium. Yeah.
It's probably what you were talking about at 100 and something degrees centigrade.
Yeah, one's like 140 degrees, one's 118 degrees. But yeah, I don't know too much about the quantum level crystal kind of stuff, what's happening. I'm more of a Newtonian clockwork guy that throws in a little bit of the idea of Einstein's gravity. But, you know, I'll even switch to Ken Wheeler's gravity, and I'll even switch over to
we were having a whole
idea
about Ken Wheeler actually over on the Alien Scientist YouTube channel chat. There was a lot of discussion going back and forth about his theory.
Jeez, we're gonna have to get Ken on and just put him through the gauntlet.
He's awesome.
Go for it. If you can roast him, because he seems to know a lot more than he lets on, and I don't think he's allowed to let on anymore. I think he just knows enough.
It's just the front, man.
Yeah, he's teasing. He's the angry photographer. I know why he's angry too.
Prove it. Yeah. All right. Yeah, I would love to get him on and drill him to the wall. That would be awesome. Run him through the gauntlet.
Well, I don't know. He's pretty sharp. I think you'd have a rough time getting him in a corner.
Yeah, Jeremy, but I would pay to watch that show.
Yeah, get him on, Jeremy. Send him out a challenge, just like I'm sending out challenges on the Gravity Alchemist. I might as well do something. I'm not getting any younger.
It didn't do my screen share on this. Maybe it did. Whatever. It's doing the screen share on there already. All right. We have a $20 super chat. I didn't even notice. Adam Solar gave us $20. He said, "Thank you for putting this group together." Well, it's an amazing group, and I'm glad it's no one individual that can take credit for that. It's all of us, you know.
I think it's mostly Tim Ventura who's been reaching out to, because Tim knows everyone.
I got to get Tim on for an interview too. I've been talking to him about it. I meant to get him on earlier this week, but I just didn't get around to it. But I want to promote it like ahead of time so that people know it's going to happen, because I do want to get like to talk about Tim in some of the what I call the ancient history, even though it's only 20 years ago and 10 years ago, about how he got into all this and got me into this, you know, back in the day when I started studying a lot of this stuff, and there wasn't much information about it anywhere. He was one of the few sources early on. So
Paul Violet, who until just recently was my hero. And then he came on and like threw all of physics in the garbage in the first 5 minutes. And I'm like, I tuned out after that.
where's that slide? I gotta find him on. That was funny.
Come on, why'd you do that?
He threw all of it, and then it's all disinformation, right? That was interesting when I had Brian Keaton on my show, and he said like he was arguing. He made the comment about my videos. He's like, well, I'd be hard pressed to say what's disinformation or just misinformation, because it's like, do we really need like someone pulling the strings to misguide us, or are we already just like as misguided enough on our own? But yeah, he made a good point about that. It's what's disinformation versus what's just misinformation, and I just say like let experiment be the arbitrator of competing hypotheses, right?
Yeah, because experiment can never be wrong.
Well, this was interesting stuff. Let me go back to the screen share for you guys, and I want to go into some more stuff. We were talking about this earlier on. Where's the schedule? So we were talking about with Ron Kita's presentation, and he had mentioned some of this stuff, and someone brought this up in the chat while he was talking about this Holland fellow, Edgar Hollingshead. And the Odic ray. Have any of you guys ever heard of that?
Ron, why don't you unmute yourself so you can comment?
Yeah, I've done quite a bit of reading on the Odic ray. Sean, I have to give out a huge thanks to, because Sean has done his due diligence digging up every piece of information he could find on the Odic ray, and we put together a nice little folder on it. But I'll tell you what, there's not a lot of information out there. The only thing that is available to look at in terms of technical diagrams is one patent of his that's not for the Odic ray device, but it's basically built like an X-ray machine with a variable distance set of plates where you can actually adjust, how they move in and out from each other. And that's what you see in that picture too, is you see this sort of like, louver mechanism, like an old camera. And I'm guessing that the patent that he released and his Odic ray are related devices. But in either case, what he basically claims here, to kind of summarize it, is, yeah, he claims that he can hit materials with this ray and he can make them vanish or vaporize in a matter of seconds. He can make materials levitate. He can take X-ray quality pictures without the X-ray radiation. Very similar to the way Tesla claimed that he could take X-ray-like pictures or exposed films without the dangerous ionizing radiation. So, which is technically possible by simulating the same type of wavelength of a impulse potential, but by having it be non-symmetrical, the scalar impulse potential, you don't end up with that same type of ionizing radiation because the amplitude over time is different. So there might be something to it. I just wish there was more, but I don't think that there's really much to dig up in 2021 on the Odic ray.
The 1920s, man, they show this machine that he's got, and it says that it can turn off gravity and
well, you know what will kill you, Jeremy, is if you were around in the 1920s, he was building these things and gave a few away to his friends. That's what'll really get you. You could have had one if you were around at that time. He might have made you one. Yeah. And now where are they all?
Ron, do you know anything about this Odic ray device?
Oh, I'll tell you what. Can I change the subject a minute? Hello?
Yeah.
Okay,
yeah, you're welcome to.
Okay. I was thinking this is going to be bizarre. As I mentioned, Tanya Slowacki put me onto a woman who holds a bunch of patents on catalysis. She's She started out. She went from basically college. She didn't get her Bachelor of Science. She graduated with her BS and her MD, a doctor. She was an anesthesiologist for many, many years. Anyhow, one thing that I saw that she claimed to be able to growing huge crystals. And I go, oh my God, these huge crystals. I never thought you could grow a crystal beyond us. I mean, like quartz crystals, you view them as a certain size, a certain density. Evidently, I think these crystals are very, very huge and very, very light. And in terms of bizarre, when you see I'll have maybe Jeremy or somebody, I'm going to give you the Rex research, okay? The experiment is, have you ever heard of KOWSKI Frost, Frost experiment?
Is this the guy with the two plates, the diamond-shaped plates with the resonating specialized waveform and the crystal floating between them?
Well, there's a picture of the guy in a overcoat with a black hat on.
Yep, I know exactly what you're talking about. That
How
is
do you
a
spell
hugely
this?
Controversial article.
Yeah,
Okay.
I have a bunch of stuff on the drive on that.
I think maybe I always doubted it, but I'll tell you what Rex Research has on it. Did you ever look at Kowski, K-O-W-S-K-I?
Yeah, we checked out the whole Rex Research page on him, and Sean has additional information as well. Plus, we dug up some old pages from archive.org.
I have a strange feeling it may be true. I'm staying away from fringe stuff with her. She's a very grounded person. I don't want to lose. So, as I mentioned, at one time I was in contact with Dr. George W. Buckley of 3M, liked a lot of stuff. Well, 3M makes electrets Swiffers. The Swiffer is electret. If you go into 3M and you type in electrostatic stuff, you get a lot of crap on it. And it was just unfortunate. I didn't know the woman I was talking to was the head of product development and didn't want to become associated with three. Oh, there we go. With three. Yeah, that's it. It might be true. I don't know. I will try to find out.
My final opinion on it was that after having done a lot of research on it, and then supposedly the author is going out and talking about some of those little drawings they have in the background. You notice how it's kind of strange for a lab to just have these big poster-like drawings stuck around the lab and in the pictures. Well, apparently they threw those in there to sort of poke at them later and say that these are just basically audio amplifier circuits or rectifier circuits, and they threw them in there for the technical aspect of making this kind of hoax article. But whether or not that's actually true, I don't know. But if you look at the schematic diagrams, they are kind of out of place, and they don't really show anything particularly unique, just rectifiers. So,
yeah, but do they show the crystal?
It is the thing is though that I think that it has all the markers of a technology that might actually be traceable back to something else. It's almost like somebody took some information that was and sort of created this hoax article about it. But I have a feeling that there might be more behind whoever wrote it.
Because there was something I saw very similar, and I forget what it was anymore. And then there was this magic gravity box, and then I started looking at it, and I knew. I mean, you look at it; it's really complex. And then when you realize that it's really something not at all, it was patched together. So this can be patched together. But like I said. When they said about the huge crystal, and then I realized you can grow these weird crystals that they must be low density. I don't know. Has anybody worked with fume silica? Is that familiar? There's something if you want to that I have. It's called cabosil. If you want to bring up cabosil, CABOSIL. There we go. I always, every once in a while, I'll make an electret and throw in fume silica as a charge additive. I think in some cases it might be worthwhile. The stuff is so damn cheap, and it weighs. There's no weight to it. it feels like an empty container.
Hmm.
The way they make it, how is it? I think they mix urea with it's water glass. You're familiar with water? There's water. There's a silica that's very. There we go. Yeah, that's exactly what it is. And what they do is they burn it in a fire, and you have this stuff that is just it is glass to such a light degree. Imagine a light snow, and imagine maybe like 3 times lighter than light as snow. It's weird stuff.
Look at the fibers. That's the SEM thing of the fibers.
Yeah.
This stuff you do not want to breathe in.
Oh no! Oh no!
This is like the worst of the worst for silica. Yeah, this is bad.
And it fumes like crazy. If you open the lid, you'll get a column that follows it up. Luckily, it settles down within about 2 or 3 minutes. But in terms of instant silicosis, but Cabot makes it. It's used on an industrial scale to a degree. It's a thickener. They use it as a thickener in the FRP industry. When you're making polyester styrene fiberglass, and you want to make a gel out of it, you throw in
Instant.
There you go.
Instant silicosis.
Yeah.
Bad news.
Bad news. Do not. Yeah, just gotta be warning to people.
Mercury's the same way. There's if you have mercury in the atmosphere, it'll plume up mercury vapors, and I see these videos of these guys experimenting with it back in the 50s and stuff, and they're not wearing anything, and they're rubbing their fingers through it, and they got a big trough of it right there. I feel so bad for their families because I know they probably didn't live very long.
Mm-hmm.
Oh, also, I should have saved a picture of this, but on rainy days when they couldn't gold mine, they would save all the mercury that they got from mining, and they would throw in gold. They would heat the mercury up and they would cook the mercury with gold ore to get the gold out, to get an amalgam. And they did it under a tent.
Yeah. Those were the good old days, man.
I guess when they use the word mad as a hatter.
Exactly.
Mad Hatter.
Yeah. There's the double bond oxygen. Really weird.
Ron, did you have any accidents with the benzene rings?
I'll tell you what I had. I'll go back. I worked in the FRP industry. When I started out in textiles, I had my own. Well, my father started several textile businesses that I eventually got into. And one day he said, "I'm retiring." I said, "What do you mean you're retiring?" He said, "Yeah, I'm retiring. I'm going to go down the floor." He had a camper. So I'm going to take the camper down back and forth. We turned out 5,000 pounds a week. And where am I going with this? By making various substrates. I made a substrate for a company that they made a lot of money making the ductwork, the air ducting on the Mack trucks, all that heavy ductwork for air. They were like $200 a piece, and the ingredients were probably like maybe $15. And anyhow, they needed a socking material, like the sock on your foot. And I wound up knitting it for them. And then I wound up to some degree doing some work with styrene. And from styrene, it wasn't much exposure, but there's something called sarcoidosis. And sarcoidosis is really a strange, they think it's of a environmental or genetic, a combination of a genetic disposal. But anyhow, I came down with sarcoidosis, and they thought it was bronchial lung cancer, which was inoperable. And this was in 83 or 84. If it was 84, I was 40 years old. and there wasn't much they could do with me. And sarcoidosis belongs to the NORD, National Organization of Rare Diseases. They get so few cases of it that they don't bother. The government gives research people some money because it's not covered by anybody. And my doctor, he happened to see one case of it. He says, you take aspirin for a month and you either get better or you go away. So I took aspirin for a month and I got better. So in terms of going from bronchial cancer to having this whole weird thing go away, it went away. And the other one was I was working with toluene diisocyanate in the lab. I was doing a bunch of calibration of mixing equipment, and it was all done extremely careful. The 3 layers of surgical gloves under a hood, and I would change out my rubber gloves frequently so the TDI wouldn't get through. And what happened, it knocked out my lymph nodes from my wrist all the way up to my armpit. My lymph nodes were about the size of a quarter at least, and I had like 3 or 4 of them. Luckily, you don't realize you have a lymphatic system until you get involved with these chemicals. And I'll tell you what, in terms of your lymphatic system does a good job, but in terms of it going to lymphatic cancer, that's why in terms of a lot of these things, even though they may look very simple, the slightest exposure, even under the most controlled circumstances, it's just that's why I warn people. You know, you have no idea. Here's TDI, 58 milligrams per kilogram. That's quite a bit. That's for a lethal dose. And then the LC50, killing 50% is in air. It's 600 milligrams per cubic meter. Despite its low toxicity, is classified as very toxic by the. I'm not sure who wrote this. It almost seems like a. There's methylene. Yeah, it's more toxic than. It's kind of right in a strange way, but in terms of getting exposed to it, it can really screw you up. And so when they list it as a very toxic by the European community, I'd go with the European community.
Oh, I'm glad you made through it, Ron. I had a customer died from that. He was just a young man. He was under 30. He had a child. He worked in a styrofoam factory. And one day his wife came into my office and said that he was gone. So you can't be too careful.
Also, you're dealing with the material. Styrofoam charges. And when you have something that's charged, it gets kind of strange. The reactivity is not the same as a normal material, and it can get to you quick. It's no doubt. Myself, when I work, I'm always doing something, but in terms of exposure, I do things between that keep me clean. Like I don't do things intensively. Someday I'll run something for a few hours, but the main thing is just to stay clear of the stuff because it doesn't take much.
Yes. Oh, sorry, did I cut you off? Anyway, I was going to say I started taking molecules from this Dr. David Sinclair that's supposed to tune up your chromosomes with these things called serotonins. You take this this molecule called the NMN, and NMN supposed to your serotonin gets demented, and supposedly if you take resveratrol and this NMN, it fixes your chromosomes, and so it fixes the brakes on them. And I've been doing it now for about 6 months, and I really like it. It's awesome.
Yeah. Well, here's something that's interesting. You know MSM? Monosulfonyl. It's the one they use for joint supplement. And,
no, I don't. This is a vitamin B derivative, and with resveratrol.
Okay, cool. MSM if you Google MSM and breast cancer, MSM kind of wipes out breast cancer. And it's basically a version of DSMO, which is dimethyl sulfoxide. And because I was looking through DSMO because it's such a great solvent. If you want to, my son's has a PhD in polymer engineering, and in terms of this is a MSM diet supplement, and it also it's also used cutting. It's a cutting agent for meth because it's really kind of and not a nerd, but anyhow, in terms of I put it online in November, the National Breast Cancer Month, and the source is the NIH. The NIH talks all about MSM as a cure for breast cancer, but yet in terms of getting any coverage, they really don't get any coverage.
Yeah. Interesting.
The lethal dose. Oh, wait a minute, that's strange. Lethal dose of MSM is greater than 1.7 grams. Because there are people who are, my mentor, Dr. Rhodes, had a hip problem, and he was taking about 6 grams per day, and he was
No.
I have no voice here. Hello?
Take that off my screen. Yeah, on my screen, I've got like a computer image of something. Yes, thank you.
Oh, so anyways, like I said, Googling of MSM and breast cancer and visiting the National Institute of Health, it gives a lot of information there. It does. I'm not sure why it never. The fact that MSM, I think I buy MSM from. You have Tractor Supply. We have it's $2 for it's $18 for 2 pounds, and it's like almost a year, not a year supply, but it's really strange stuff. In fact, most of your joint supplements are chondroitin, glucosamine chondroitin, which is basically chitin, and the solvent MSM. And the number of people who are taking it, when I go to a drugstore, I look at the supplements that sell in terms of if you have 1 or 2 on the shelf, but if you have like half a dozen or a dozen of something and it's moving, and these are all MSM, glucosamine chondroitin materials, and so people are taking them, and apparently they're getting a benefit from it, and that's what I watch for. I watch for, what's moving and what it's contained. But MSM is really a very interesting material.
Cool. Well, that's awesome. I might check that out. I don't have any joint problems. As a matter of fact, since I started doing this regimen by Dr. David Sinclair, it's been, I take a gram of this NMN and a gram of resveratrol every day. And I tell you, I feel about 20 years younger already. And I'm hoping that I can live long enough to get my propulsion device working.
Okay, good goal.
Well, looks like we're it.
Okay. So I guess at 10 o'clock. Okay, we lost everybody. Okay. Okay.
I'm still here. I just.
Okay. I think at 10 o'clock, maybe a few minutes.
Well,
I'm gonna step out. So I gotta find something of a snack to eat. I managed to get through dinner here, and
I'm cooking dinner right now. That's why I just stepped out.
well, I enjoyed it, everybody. I'm going to check out too. I'm looking forward to the next one.
Okay, yeah, because it's like 10 o'clock, and we'll see what happens. And the main thing is there are so many resources there. I believe in Thomas Townsend Brown. There's a lot of people who don't. Like I said, he got into rock electricity for some strange reason, and whether that's tied, I simply don't know. But in terms of the Electric Spacecraft Journal, I used to subscribe to it, and I think Jeremiah, somebody has the complete set of it, and so that and Jim Cox had his anti-gravity news. Oh, there is one thing in anti-gravity news. The guy's name, it's Yamashita, Yamashita, Haruo, Haruo, and he has a Japanese patent. And what he does is he spins a drum that he charges, and it's in a box, and it loses quite a bit of weight. It's been around, oh God, maybe since like 1998. Some people have tried to duplicate it, but it probably loses maybe 5%. Well, I have it. What I'm going to do, I was looking for the patent number. It's a patent. I think it's a Japan patent, and a lot of it's been translated. But all it is a spinning drum, and if you spin it one way, it gains weight. You spin it the opposite way, and it loses weight. And the guy who ran the experiment, I think, was correct. And there are people who've tried to duplicate it, and unless you get it right, some of these experiments, the people have worked on for years, and to work on something for a week and say it doesn't work, but it's I'll get it out there because it's
it sounds like Benjamin Solomon's deal. He said you spin it one way, it loses weight.
Yeah.
And I guess you spin something fast enough for some reason, it'll lose a little bit of weight. But I'm looking at making a device that will actually go to space from the surface and doesn't have to reach escape velocity. It uses torque and
well, Gravity Alchemist, maybe I can ask you a quick question about that. Are you utilizing MHD systems, EHD systems, or something like that that's reactionary against the atmosphere, or is your system entirely independent of that?
Well, that's what I'm looking at is seeing if an MHD system, I asked the questions about liquid momentum wheels because I was real interested in liquid momentum wheels, and they use an MHD system to spin the liquid, but I don't think the liquid's spinning fast enough. I'd like the liquid to spin about 50 meters per second.
Let me ask you a different question to get right down to the heart of it. Does your device utilize any of those systems to generate forces internal to the engine, whereas it can operate without an external atmosphere or the necessity for a reaction mass like air or something?
No, it doesn't. Yeah, it could work. It'll work in space great. You just got to have electricity. So in other words, I'm looking at outboard RC motors that run on, I'm looking at one, it's 1.5 pounds, and it can do 20 horsepower for 3 seconds, or it can do a continuous 15 horsepower and only weighs 1.5 pounds. It's going to have to perturbate this liquid pretty darn fast. And and there's actually going to be 4 of those motors on the device. So they're expensive too. They're like $500 a piece, and in my economy, $500 is a lot of money. I live modestly, but I'm looking at getting a grant because I'd like to take this further. And I do know I could make something inexpensively to prove the concept that would float in a swimming pool, just using torque forces. And there's actually a collision involved, but I'm not going to say anything about the collision yet.
I guess I would ask this question. In order to build a device, not necessarily that can levitate or do anything fantastic, but just a simple proof of concept to show that there is a possible force that you can generate there, how much would it cost to just build the simplest proof of concept possible?
I've already got the motors. I got everything to build it with right now, and that's what I'm working on. That's why I bought some of these discs. So, I mean, I will do it. I'm just procrastinating a little bit. The proof of concept is, if you look at my video at the website, I got a hammer that spins that shows the center of mass. And if you can imagine changing the hammerhead from from the hammerhead at the center of mass, and when the handle is at its apogee in the flipping physics video. Could you imagine shooting the hammerhead to the other end without violating Newton's third law? That's my whole thing right there. So
check this out on your website. I mean, it's going to be.
I got thousands of videos on there, and it's kind of encrypted, but it's kind of a treasure hunt because I got hints in there about it. In New Mexico, we have Forrest Fenn had a big treasure, and he made it this really neat treasure hunt. And so I'm kind of trying to mimic that a little bit in my website to do the treasure hunt for the device if you figure out what it is, or if you want to be involved with me.
Yeah, I just want to be able to find some of these videos on your site. If you have a simple principle type of device that can be constructed, that we could construct, we would be interested in also doing a simultaneous replication with you. That
would be awesome. See, the whole thing, the way it would travel in space is that once you get it up in the air, you have to change the center of mass and then rotate it 1 pi radian. And you got to do that faster than the center of mass is falling when it first takes off, when you first get it up in the air. So it begins to fall back to the earth at 9.8 meters per second squared. And so is what you have to do. You got to rotate that. You got to dynamically move the center of gravity and then rotate it around it again before the head falls back down to the earth. So you got to do this pretty quick. So if you could do it, and this is pushing it. So I don't know if the physics or if we have the equipment to do it, but in other words, you got to change the center of gravity and rotate around it faster than it's falling back to Earth. So I was thinking if you could go 32 times a second, and you could rotate it around and move it 1 foot, you could move 32 feet per second. So that acceleration would be equal to Earth's gravity. But you could even pump that up by spinning the liquid faster and exchanging. It's all about changing that center of gravity. So I was thinking if there was an electronic way to change the center of gravity using some of these methods like Ron talked about, if you could just put an electric force on some kind of material that changed its center of gravity, you could make that sucker go. You'd only go a half a foot but go 180 cycles per second. Be a nice smooth acceleration.
It's like if the system actually generates a force because of the motion or because of the asymmetry of where the
momentum the same reason why a satellite rotates around its center of mass. So whenever you have a reaction wheel on a satellite and you want to point it at a different attitude, you can either if you accelerate, if you break into the reaction wheel, you're going to go the same direction as the reaction wheel, or if you accelerate the reaction wheel, you're going to turn your attitude opposite the direction of the rotation. It's as simple as that. It's the simplest. It's a simple idea. I'm kind of a reductionist in that regard because I believe Einstein's right about curved time space. I mean, not curved time space. Well, he is right about curved time space, but if you have mass going around in a circle in a really small area like a disk, it's bending mass through time space. And if you think about it like that, there's a lot of things you could do there. Even though, so you're talking about bending time space, or I am, and on a very small scale. And if you can do that, which I don't see any reason you can. If you watch the 2 videos I got on Hosenfelder and Sabine Hosenfelder and 60 Symbols, I think it's called. If you watch those 2 videos for a while and get what they're talking about, Einstein said there's no difference between acceleration and you couldn't tell the difference between acceleration and gravity because gravity is a pseudo force because you're going through curved time space.
So if you don't mind me asking, so your inventions are predicated upon the axiom that relativity and gravity are constants and that the lambda CDM model is correct?
Well, you just went over my head. I'm not a scientist, okay? I know a little bit about gravity, and I just do it from observation, the way I see things spin, the way I watch some of these videos. So when you talk about lambda, I don't know what you're talking about. When you talk about, I know what general relativity is, of course. I don't know the Lorentz transformations, or I couldn't go into any of the mathematics on it. I think I could figure it out if I really concentrated, but
I mean, the only reason why I bring that up is because when people say, you know, Einstein is right or is not right, that's been contested in the last, 10 years by various people like Dr. Don Scott and Walt Thornhill, and they have a lot of experimental evidence that have been since been independently reproduced and verified. And it's behind the closed doors of academia. It's really looking like that Einstein may have actually been wrong, and that space-time curvature, gravity lensing, that actually may turn out to be a very wrong assessment of the data from interpretations that were
really
concluded because they lacked proper data and evidence. For example, Einstein, when he was creating his models based off of pure gravity, at the time plasma wasn't even a state of matter. There were only 3 states of matter. Now there are dozens of states of matter. It wasn't known at the time that light could actually react with and bend itself. Now we do know that, which relativity predicates upon the necessity that only gravity can bend light. There's a whole litany of issues, but our entire model, our contemporary models of physics are fast breaking down. And we're kind of going back to the mid 19th century here and having to go back to, we have no idea what's going on.
Well, I kind of understand that. The quantum world may come up with something that they can produce, so many electrons out of the bottom of a ship that they could accelerate with it. But to me, just torquing time space, torquing matter through time space, and being able to do that very quickly still makes a lot of sense. I know there's a lot, like Ken Wheeler always rails against Einstein and this and that, but the guy with a smart old code, I don't think they've ever really disproved him. At least a lot of the physicists I've talked to said that.
Well, let me ask you this: how do you know that you're transmutating matter through time space and not through some other mechanism?
Well, Einstein even said that it's not time space, that there was a medium that light had to propagate through. And he came out 20 years later or something, said that, yeah, there is an ether. I've got it on my website. He actually made a statement that there had to be some type of ether or light would not propagate. And so
interesting. I just wanted to put that out there that we probably should be a lot more provisional.
Where they were defeated constantly in their beginning, but they were.
We've come a long ways, I know, since Einstein, but still, I don't see any real proof that they've discredited him, other than that he doesn't. That the great Frank Wilczek, Nobel laureate, said that that the triumph of the ether, that Einstein was right, but it would follow the equations of Einstein's special relativity. It would have to follow the equations of Einstein's special relativity. Now, I'm not a mathematician, but I take his word for it. So I've got that video on my website also. I've not tried to direct everybody to my website, but I've got Frank Wilczek talking about the triumph of the ether at the Arizona Science Festival or something like that. And then I used to do videos for Ayurvedic place, and there was our resident physicist would come in and we'd talk, and he'd always tell me that they've never proved Einstein wrong. All of his math is right. So it may not apply to the same kind of time space that everybody's thinking of at the quantum level, whether it's
Well, I think really what we're getting at is they've never proven that space-time is curved and therefore light curves around matter. What they have proved is that light curves or electromagnetic energy moving through space curves around gravitic masses. So gravity affects electromagnetic field. Doesn't prove that space-time is the curvature, that gravity is the curvature of space-time. That has never been proven. I don't know if it is.
what was when Eddington shot looked at those stars behind the sun during the solar
That doesn't prove
eclipse.
that space-time is warped. It just proves that light is affected by gravity.
Yeah, it is. Yeah, it's bent. Of course, you look at those ferrocells, and you can see that clearly in a ferrocell.
What do you have on your face? Glasses. That also bends light. Does that mean that space is warped around your? Are your glasses warp drives? No, they're not. There's just ways of speeding up and slowing down the speed of light, and that's how it curves inside your glasses.
Right, it bends. Yeah, the glass.
Bending effect doesn't mean
it's
that
a refraction.
gravity is the warping of space-time. That has never been proven. I don't even know if it is provable. But my problem with it is that warped space-time, that theory leads you down to the Alcubierre drive, and you need negative matter in order to create the warp drive. That there is no negative matter in physics today, and it's pretty much a dead end as far as flying saucers go. So I'm saying that part of Einstein's theory has never been proven. It might be wrong. His math can all be right. But that doesn't mean just because he got one thing right doesn't mean he got everything right.
Well, there's being contested as to what extent he got anything right. For example, relativity necessitates and is
he got the atomic bomb right.
What do you think that he got right as far as you're aware?
The atomic bomb. He
perfected.
No. Einstein had nothing to do with
Oppenheimer, Einstein.
Einstein had nothing to do with the atomic bomb. That was being worked on by people like Niels Bohr decades before.
Well, that was based on some of his mathematics.
No.
The theory
his mathematical model describes one mechanism by which you can quote unquote convert matter into energy. However, that mechanism has many competing mathematical models, and they're all functionable.
His theory.
Okay, well, like I said, I'm not a scientist, but I just go on what the mainstream that I see is telling me, and that's how I came up with my theory.
The mainstream is hot. I can say this with a high degree of certainty, is that the mainstream has been for a very long time irredeemably corrupt. There's been way too many egos involved. The scientific method has long been thrown out the window in favor of protecting established interests and established egos. And there are many examples of this in the real world today, and even going back decades. The whole reason why quantum physics had to break off is because very powerful, very well connected special interests within academia actually tried to shut down quantum mechanics and lump it in with basically magic and pseudoscience. And so the quantum physicists said, okay, screw you. We'll go over here and we'll create our own field. We'll create our own discipline of science and research. And the relativists tried to shut them down.
Right. What Einstein actually did is he perfected Newton's mathematics and threw in the whole space-time thing. But the ultimate equation equaled up to exactly what Newton already had. He added one piece of math which wasn't really his in the first place, which was based off of Mercury's perihelion precession, which is the closest point where Mercury reaches the sun, and it would change every rotation. That's the perihelion precession, that as it moves around the sun every single rotation. And at that point, they realized, after having so much data off of Mercury from actually looking at it in the sky, they knew that the perihelion precession was changing at a rate that couldn't be described by Newton's theory of gravity, and a piece of
Correct.
math had to be added to it, which included R3, which is the distance.
But Einstein's math
That's the only difference between Einstein's math and Newton's math.
It predicted it perfectly.
Well,
Not perfectly, but close enough.
if I may, Mark. So here's some of the things. We'll go down just a brief list, of which there are many more that I'll omit for the sake of brevity. But there are many things that relativity necessitates in order for it to be considered an accurate model of the universe. It necessitates that light in a vacuum is a constant. It necessitates that light can only be bent by gravity in a vacuum. It necessitates that nothing can travel faster than light. It necessitates that gravity itself be a constant force. It necessitates that, given our observations of the universe, that 98+% of the universe must be in the form of dark matter and dark energy, for which there is no evidence for its existence. All of these things must be true, otherwise relativity is not true. One of the things that we know to be true is something called quantum tunneling or electron tunneling. This happens in circuitry all the time, and it happens at a rate that is instantaneous. This information propagates at a speed, or transfers, or warps, or tunnels, however you want to describe it. It does so faster than light, instantaneous. It breaks
That's
relativity.
how wormholes work.
Now, well, that's the problem, though. The general relativists say, well, the electron is traveling through a wormhole, which allows it to jump the gap in the circuit. And to that, I say you have to show the wormhole, otherwise you have no evidence.
No, it's not. There's nothing moving. It's just all the protons are singing and dancing to the same tune.
No, it doesn't matter.
When it hits the wall,
information is being transferred faster than light via quantum tunneling, which breaks relativity, regardless of the mechanism.
Oh, can I make a comment here? Hello, am I here?
Yes.
Am I on board?
Yes.
What I wanted to say is, I guess everybody knows about the Eddington experiment, of a confirmation of Einstein, the experiment conducted off the Principe Island on the equator during the eclipse of 1919.
Yes, I'm familiar.
Yeah, okay. Well, what it is, the bending of the light was 1.75 arc seconds. 1.7 arc seconds is so minuscule as to be, I mean, it's an incredibly low number. And also what I wanted to add, it's almost escaped me. There is a paper at my website, chirolex.com. I make mention of one of my mentors, Professor R.C. Gupta, G-U-P-T-A, and he has an AXIRV paper called Gravitation as a Secondary Electrostatic Effect. He was inspired to look for a connection between gravitation and electricity. He was inspired by Nobel Prize laureate Abdus Salam. And it drives Jack Sarfati nuts. And also Gupta penned a paper. It's entitled The Deflection of Light by a Nearby Star, meaning our sun, as a Refractive. It's basically a refractive phenomena and nothing more. And it can be found by using the search descriptors Kita, my patent is mentioned in there because it's electrostatic. The descriptors are Gupta, G-U-P-T-A, refractive, gravity, and I think Kita gets you the thing, and it gets into gravity is simply being a change in refractive. There's nothing to it more than a refractive effect. So that's my
then it's just optical, you're saying, Ron?
We know that plasmas, and we know that even light can bend itself. This has been recently discovered, and it can bend itself in a far greater degree that so-called gravity wells can. Not only that, in order for the current lambda CDM model to be functionable, it necessitates that inflation hypothesis, which is the idea that the universe is exponentially expanding, be true. The problem is that in the 1980s, Holton Arp, Holton Arp was the protege of Edwin Hubble himself, and Holton Arp had continued his work after Edwin Hubble had passed away. And Holt and Harp had actually discovered that there were matter bridges connecting quasars to stars and vice versa. And these matter bridges are fairly close to each other, right? He established that these stars were very close to each other, to these quasars. And what was happening is he had observed that there were quasars and stars that should be blue shifting when they're red shifting, and should be red shifting when they're blue shifting, and vice versa, respectively and otherwise. What this means is that the only piece of evidence to support inflation hypothesis, which is, like I said, the idea that the universe is exponentially expanding, is that when we peer out into the furthest reaches of the stars using our telescopes, we see that most things have redshifted. The problem is that that's predicated on the assumption that the redshifting is occurring due to the Doppler effect. Now, the Doppler effect, of course, is that anytime you move away or towards something, those waves will be either elongated or squeezed relative to you, to your distance, right? So if you move towards something, just like with sound waves, if something is emitting a sound and moving towards you, the sound will appear to be a higher frequency, and if it's moving away from you, it will appear to be a lower frequency, such as when an ambulance passes you. The same applies to light waves. The problem is that Holt and Arp had discovered that there are alternative mechanisms by which stars can redshift and blue shift, respectively, that do not necessitate the Doppler effect. And there are other competing theories as well, other than even Holt and Arp's observations, such as Zwicky's tired light theory and many others. And all of these different models are very functionable, and indeed have been more accurate in some ways at making predictions than Lambda CDM model, for example.
That includes time dilation.
I'm sorry, what?
Does that include time dilation? And
so time dilation is a very special thing. So time dilation, when humanity was first launching satellites into orbit, the relativists were stating that time dilation wouldn't have any effect on satellites, that their calculations showed that at the speeds that the satellites were orbiting, time dilation would have basically no effect, or would have literally no effect. What they discovered is that it turns out there's a huge effect. The problem is that there's no connection. They had to alter their mathematics to account for this. But even then, they're only accurate within a degree of probability. That is, they have a tolerance accuracy, meaning that their model isn't quite accurate per se. But what's more interesting is that the cosmic background radiation can actually affect the rate at which clocks operate. This is called clock dilation. It applies for both digital clocks and analog clocks. It has to do with the interaction between plasmas and Birkeland currents, specifically cold and visible plasmas and Birkeland currents. And these mechanisms can actually cause the phenomena that we know to be time dilation to manifest and emerge absent of any time dilation. And we know this to be true, so we have to reproduce, to prove time dilation, we have to actually reproduce an experiment that accounts for, to try to observe time dilation and isolate for invisible plasmas and cosmic background radiation, and nobody's yet done that.
I have a design of experiment. What you use is a coronal mass ejection. Okay, so what happens is certain isotopes, their radioactive rate of decay changes before and after a coronal mass ejection hits our Earth. And basically what's going on it's a type of gravitational diode or rectification is what's going on. First, you have the flash from the initial shock wave that moves at the speed of light, and it takes about 7 minutes to hit the Earth. The coronal mass ejection, on the other hand, takes part of the chromosphere of the sun and throws it out into space at the speed of hypersound, and it takes about 2 to 3 days to hit the Earth. But it's like a gravity wave. It's like a big wave, 1 million miles long, that heads towards the Earth. And then when it hits the Earth, that's what causes our magnetic field of our Earth to go swinging around. And sometimes you'll get blackouts because it'll charge up transmission lines. But in any case, that's an example of what I'm talking about. It's a gravitational effect from the sun, where the matter, you have a proton flux that's coming out of the sun, and it's creating a shield around the Earth and in the solar system out to the edge of the Oort cloud. And then there's cosmic radiation coming from intergalactic space it's protecting us from there. And that's what one of the reasons we can have life on Earth is that, combined with the fact that we have a magnetic field to protect us. So
Well,
there's lots of there's other examples of this phenomena too. You ever heard of sprite, a lightning sprite? It's
I've heard of it.
It's a type of lightning that goes up instead of down, and it's blue or violet because it's shifted. It's blue shifted as opposed to red shifted, and it's because it's going so fast. And what it is, it's it's positive lightning as opposed to negative lightning, which goes towards the Earth.
Yeah, I was told about some proton storms, not proton, positron storms, that they actually, some of the weather planes actually measured them. So positron storm, I don't know if that'd be very healthy to fly through one, but I like I said, I don't have a deep universe of science. I know there's a lot of theories. Everybody's got a theory, but basically the relativity and then the quantum. I don't understand. The only thing I know that goes faster than the speed of light are those quantum entangled particles that, one spin up and you can have the other one on the other side of the galaxy and it spin down. And when you look at it, and that's another thing that's kind of bothers me is in quantum physics. You look at Schrodinger's cat, is it dead or alive? Did the isotope kill that cat, or did that, when you look in there and the cat's dead, is he alive in another universe? I mean, this stuff is pretty far out for a country boy.
Well, an example, that's the Schrodinger's cat is an example of quantum tunneling. So that's what happens in the quantum tunneling phenomenon.
So you're saying that the cat tunneled into another universe?
Well, no, I'm just saying that there's this interconnectedness on both sides of this barrier, so-called barrier.
I know about quantum tunneling.
We call it time.
But I didn't know quantum tunneling was faster than the speed of light. I thought it had to give up, it had to gain some momentum to get through it, but when it got through it, it had to give the momentum back.
It's instantaneous. It's instantaneous, and what you got to think of, it's like, what a standing wave is?
Yeah.
So it's like a standing wave. It's like as one side of the wave goes through the barrier, it's got one magnitude and direction, or spin as they call it, and on the other side of the barrier it has the opposite spin, and it's instantaneous. It's like the wall's not there.
Oh, okay. So that sounds like, to me, like Ken Wheeler's that inertial plane where the magnetic field is coming out of the magnet from that inertial plane, one's spinning clockwise, another one spinning counterclockwise through that. He calls it
kind of like I described. It's the protons don't move; they just sing and dance to the same tune. And if they get in this state where they're, might call it harmonic convergence. It's a harmonic is where you have three different wavelengths that superimpose on each other. And they produce a big wave. You can use it to create a superposition of the three waves, or you can totally make the thing extinct. And so basically, think of that's what it is. It's a harmonic. The barrier is vibrating and moving at just the right frequency. so that the stuff goes through without time being involved. It's just because it's a standing wave. It's not really moving. It's just relative to the motion on the right. It's moving at just the right way, frequency and wavelength, so that it comes out the other side just the right way.
Well,
it's like think of space-time as a membrane. Okay, it's like in your cells. There's this molecule called ATP synthase, and it controls the pH on two sides of the membrane. And what it does, it takes protons and it spins them around. Okay, and that's what ATP synthase does. And that's the basis of all
an
life.
MRI machine spins protons around, but
yeah, lots of things. Well, and it's like a cyclotron. You know, a cyclotron takes protons and accelerates them, but a linear accelerator takes electrons, makes them go in a straight line. So that's how you think about it. Protons got more energy.
Well, my device, as primitive as it may sound, I'll find out soon if it's going to work, and I'm still feel like I've conquered it. So I feel like that my thought experiment, if I can put that into practicality, it has a chance of making a launch to orbit.
Well, failure's not an option. Failure's not an option. It's a learning experience.
Exactly.
And I love breaking things. I had lots of jobs where that's all I did is I broke stuff for a living.
All right. Well, I hope I don't break this one. But, I've made a lot of mistakes, but I'm tired of making mistakes now. But it sounds like it's going to be fun for me. And if it's not fun, then I'm not going to do it.
That's what it's about, having fun.
They say experience is the best teacher, but unfortunately the test comes first and then the lesson comes after.
Mm-hmm. Yeah, we could get into some philosophical discussions here.
Yeah, I like you guys were talking, somebody was talking about mainstream physics and, you know, the whole ivory tower mentality. And I've kind of went from being recently I've become an archaeologist, and so I used to go to physics conferences, but you know, the technical conferences are pretty boring, and frankly, physicists don't have very much of a sense of humor.
No.
But then
I'm trying to bring back put the sex back into it or something, you know.
Well, that's the thing. In archaeology, on the other hand, my wife's an archaeologist, and she used to go, and she'd never do a paper, right? And I go, well, why do you go to these conferences? And she go, oh, it's about networking and stuff like that. And I go, so finally, when I got my degree, I went to her one of her conference. I wrote a paper, and I went to go present at the conference and everything. And I noticed that nobody was in the conference; they were all out at the bar. And the other thing I noticed is that there were more women than men. And,
really?
And it was a lot more entertaining, you know, because the next day they weren't talking about who did this great paper. It was who showed up with wet hair with the other one, and who slept in the hallway.
Yeah, that's why we got to bring sexy back to physics. Okay.
Yes. Controversy and scandals, all that good stuff. Yes.
Well, Jeremy, I think you're like leading the pack there, man. I love what you're doing.
I'm trying.
I mean, you're not right about everything, but you're pretty damn good.
You're not right about
everything. It's all right. Yeah, I'm not here to be right. I'm just here to drive this forward and shake things up a bit and entertain myself and others. Hopefully,
that's cool. I'm learning. I'm a little narcissistic. I'm a little self-centered myself.
I'm working on that.
I've met so many smart people. I realize, like, yeah, I'm pretty stupid in the bigger scope of things, but you know, I try.
Honestly, I came here to be wrong so that I could be wrong in front of the right people and they could tell me how to be right.
There you go. Well, yeah, I'll keep talking. Just keep listening, and if I make it to orbit, you'll all know. Or if you want to be part of me, you can sign up.
Well, this is the race. We're all like working together, but on different teams. Kind of. This is the only public team that's going and working on it and bringing this out to the open, because there's a lot of people who believe other groups have already figured this out and that they just can't talk about it yet.
Well, you're very unusual, and I'm glad you pulled this together, because I don't know any groups that can really talk like this. And
yeah, I'd like to present at the next one if I could.
That would be great, Michael. And I wanted to get anyone of you guys who want to come on my show separately just to do an interview on my show. I'd be happy to entertain that.
How long is that? How long a time is the show go for?
This one's going 7.5 hours right now. And we've had a pretty steady stream of like 70 to 80 people watching throughout the whole thing. So that's pretty amazing.
And then a lot of people watch the YouTube videos too, I know.
Yeah, so it stays up, and then I'm trying to work on stuff like if we can get like good sound bites or good segments. The problem is that it's a lot of information. It's usually, at a high level that a lot of people like sit there and watch it. They try to get into it, but they're like, what are these guys talking about? They have to pause it and Google half the stuff we're talking about, and then do an hour's worth of reading and studying just to understand what we're even mentioning or talking about. But the scientists in the group, you mention one of these things and they automatically, I know what a Fourier series, I know what a Fourier transform is. Yeah, it's no problem. We've already been through that process, but there's a lot of new people coming into this all the time. So it's a challenge.
Working on a movie, The Gravity Alchemist.
Yeah, the Gravity Alchemist, and that's awesome that you do video editing and stuff. I
might have to edit it myself, though.
Yeah, that's what I found. Most of the stuff I kind of have to be at least some kind of an editor, have some sort of editorial skill, because I find that other people have their take on it, but then I'm like, I watch even the stuff that I watch on my old stuff. I'm always like, oh man, I could redo this now so much better, but I don't know.
Well, you're gifted. I watched your videos. I watched your editing technique. I watched, it's like Rod Serling on steroids, man. I love it.
He's a great one. I could never touch that guy, man, but we should definitely talk. I'm planning that trip out to go do this. We did a UFO road trip back in 2018, I think it was, with Michael. When I did one with Michael Schratt, and I want to do another one with him and visit his archive, because he's got a warehouse out there, and he's got a couple warehouses apparently, and I'm going to go visit one of them on this first trip, and we're going to go visit Roswell. I'm going to drive down to Roswell with Michael Schratt. That'll be pretty epic.
Well, I'd be honored if you give me a call and I could meet you. We could have lunch or something or whatever, have tea.
Yeah, maybe I'll announce it. We'll get like a caravan to take the road trip with us. We'll all go. We'll get a bunch of people tagging along. That'd be amazing.
Okay. Do you have a link to your show?
What's that?
Do you have a link to your show?
Oh, it's YouTube Alien Scientists. That's where I'm streaming there live right now, and I have a bunch of other, interviews and stuff, and I'm hoping to get more soon and talk to more people. I did Brian Keaton recently, and he's from Brown University, which is right down the street, and he introduced me to a physicist from Brown who was a consultant on A Wrinkle in Time. Remember the old book A Wrinkle in Time? It was one of the first sci-fi books that I read as a kid. It actually was the first sci-fi book I think I ever read. It was on time travel and consequences and stuff. It was pretty cool. But Disney apparently did a movie on it recently, and they consulted him to be their science advisor to kind of make sure they got the science stuff right. Which I thought was cool. So I'm going to try and interview this dude and see what he has to say about some of this sci-fi stuff like time travel and warp drives and all this stuff. So that should be, hopefully that will be cool and branches out into more people, because I want to start bringing more mainstream physics and academia and stuff in on this and work up that chain of command, chain of people, chain of command, I guess.
Yeah, that was an excellent book, by the way.
Which book? Oh,
A Wrinkle in Time.
Yeah, Wrinkle in Time. It was a great book. I remember they went back to the dinosaur. They were doing trips back in time. It was like a, rich people could pay to go back in time and see dinosaurs and all kinds of stuff. But they had to be careful about not messing anything up because they'd screw up all the space-time continuum and
time paradox.
Yeah, all the causation and causality and all that kind of stuff. Yeah. So it certainly made me start thinking about a lot of that stuff and got your mind going about those ideas in a real scientific way. So I like that aspect of it. But yeah, that guy, he should be an interesting guy to talk to. You know who else is local to here? I think he's at Tufts University, right up in Somerville, like right north of Cambridge and MIT and Harvard and all that. It's just a couple minutes from there on the Red Line, actually. Davis Square. But Tufts University is Ronald Mallett, I think. And he's been on like all the time travel episodes of this Discovery Channel. Let me just look him up so I can bring him up for Ronald Mallett. Is it Ronald Mallett? I'd like to talk to him as well. So there's a whole bunch of these guys right local to here. I'm going to start trying to reach out and interview more people that are in this area where I'm right around where I'm at in Rhode Island. But yeah, I definitely want to take this road trip out to Phoenix and then hit up the Roswell site. It would be cool because I'm working on a documentary about that, and I'd like to. And then I also have another trip planned where I'm going to go out and hit a couple spots. I was going to drive out to New York. Right. So I got here's the trip to, we're going to go to Kingman Air Museum and Chandler Air Museum in Chandler and Tucson. Probably spend 2 or 3 days, 3 days in Phoenix. Right. And a couple days going over all the files and Schratt's thing. Then we're going to drive to Albuquerque, visit David Marler. And then we were going to take a day drive to Los Alamos, spend a day at Los Alamos, go to the Los Alamos History Museum, then take a day drive from Los Alamos down to Roswell after that. Visit Wade's Bar. Maybe we can hook up with you and go visit Hangar 84 and with Michael Schratt and me in Hangar 84 and take some video of us and
I'm a cameraman. In other words, you wouldn't have to do selfies if you don't have a camera guy with you. I can shoot video pretty well.
Yeah, I have a camera, and I might bring a camera guy with me, just somebody to hold the camera. But it would be great to have another guy on the crew. I don't know if you could. I offered. If you could meet us in Phoenix and take the whole trip with us, man, that would be cool.
Well, yeah, I'm getting ready to make a trip across Texas this next week. I won't be back till April 1st. But when is your trip?
I'm thinking the end of April, maybe in May or sometime around then.
I'm retired, like I said. If I'm retired.
We'll talk about it. Let's talk about it later a little bit and plan it a little more because I'm still in the planning phase of it, trying to get an idea of it because I want to do this. Another trip I want to do, which I could even do this trip first. Doesn't matter. But I wanted to take a trip out to New York State. I'm going to drive out to New York State and visit the Corning, New York first, Corning Glass Museum. And then I was going to hit up after the Corning Glass Museum. I was going to maybe hit up the University of Rochester. There's Alien Science and Technology in Rome, New York. There's a company that I wanted to check out. I wonder what they do. And there's a couple places around on the way there at another university where I might stop as well. And then I was thinking about driving out to Dayton, Ohio and Columbus, Ohio to visit Battelle and Wright-Patterson just for the end of the Roswell documentary and kind of leave it at that. And
if you're out at Rome, why don't you stop by and see my friend, Dr. Meyerboth?
Right. Oh, this is why I'm throwing it out here so that people can be like, oh, well, why don't you stop? Because we can line up as many interviews on the way for this road trip. It's going to make it all worth it because we can stop and
Are you familiar with Lightcraft?
Yeah. Lake Marabou.
Yeah.
Hey, would you guys like to see some data that shows how time travel is possible?
Sure.
Okay, I'm going to try and share it with you right here. Let's see. Here we go.
We'd have to live in multiverses. It would have to be multiverses.
So I was exploring time travel in a discussion with Hal Puthoff, and let's assume the speed of light is our fixed time reference, with the gravitational interaction time being our variable. With expanded space-time, time shrinks, length dilates, so an anti-gravity pre-signal that we observed, and we observed this effect is shown. You can see here let me pull down so you can, this signal in the middle here, this is the gravity signal. Over here is this little spike here is from the edge of a nanopit. And so what we're seeing though is we're seeing part of that signal before the electromagnetic signal here. And that's what we would expect. And so what we have here, just so you to think about what the experiment is we have this nanopit that's 10 microns square on a radius, spinning at 500 inches per second, constant velocity. And so this first spike, that's the edge of the pit, and the second spike over here is the other edge. And that's why one's going up and one's going down, because the right-hand rule that causes the direction to flip in the magnetic induction. This signal here is the gravitomagnetic signal. So we see a pre-signal there. So that shows that in this case, the matter signal is going faster than the speed of light. Now the next likewise with denser space-time, in this case we have a nano bump, 10 micron square. Time dilates, length shrinks. So a post signal would be expected. We observe this effect on the 10 micron square bump. And here you can see same conditions, 10 microns, 500 inches per second. Notice that the signal here, the gravitomagnetic signal is delayed. And this is an example. So what's going on here is time is gravity. In one case is in one case gravity can in expanded space-time, where space-time is like, think about expanded space-time as empty space. In expanded space-time, that's where you get the pre-signal. So gravity can go faster than light. In condensed space-time, or like the closer you get to matter, the time slows down. And that's why there's a delay like we see here. So it's an actual physical effect that we can measure at the nanoscale. So it's actually a quantum effect. It's not just a GR effect, it's also a quantum effect. But it has to do with the properties of protons, not electrons. So that's the data I wanted to share. Let me unshare.
Hey guys.
How do I do that?
How do you unshare? Oh, I'm not the host anymore, am I? No. Hey, can I ask you guys for some testimonials?
The magnetic field, the one that you scrolled down again. Can we see that, please?
The first one, this one,
No, the third one. Like, yes.
This
Continue,
one?
please. No, next. Continue. Yes, that one.
okay, that's that's an image of a cross-sectional image of what's called the great attractor. So my hypothesis is that the region on the left represents the past, or the so-called Big Bang. And the region on the right, those dark regions represent our future, the voids. And that in our past, space-time was denser, and in our future, it's less dense. And basically, that's an effect that as space-time becomes less dense, basically matter evaporates. So the closer when you get closer to the great attractor, stuff like uranium and plutonium are stable. They're stable matter, and they only become unstable as you get farther away from the inner event horizon, which in this case is at the great attractor, which is a supermassive black hole. But there's an outer event horizon too. It's kind of like a cell. And space-time is different membranes. So a event horizon is just
So like leading the
it's an event, is a membrane. It's like it's like where you have two different mediums and you're looking at something. If the refractive index is wrong, you can't see through it. It becomes
So like
opaque.
we've got Voyager as one of our, like, the humanities shuttle that, has reached the outer heliosphere, correct?
Correct.
And so
The edge of the Oort cloud, where now it's getting exposed to heavier radiation levels from the intergalactic space.
So whatever that core engine is, wouldn't, and since we were able to communicate with it, would not create a continuum link for, let's say, a human core element propulsion, or that we ensure that humanity under all of those conditions?
I didn't hear you. You were cutting out there. Say the question again, please.
I was saying, like, the Voyagers, the two spacecraft, two shuttles that were launched back in the 70s. Those held a core engine, like an element, and we're still and we're still today able to communicate with them. So, and that's made by humans, and the human genome structure and the DNA is encoded on that. So, wouldn't that be like a root element for humanity's existence? And, since it's that many miles away, we have already ensured that humanity's core elements, will survive any kind of, whatever, even that doesn't even abide by our relativity theory, because now the laws of physics change and we're still able to communicate with it. So,
well, my hypothesis is that gravitational energy is different from electromagnetic energy, and the way that they're communicating with us is using electromagnetic signals, not gravitational signals. But the actual power source, which is an isotope, I assume, is when it gets to the exposure to the galactic flux of protons, which are basically like hard cosmic rays, then it could affect the power source. But I doubt it would affect it enough to make it so it wouldn't work.
Would the material structure transition to something else? Because,
no, it's not likely, because it's still going to be the same. It doesn't transmute into another element, for example.
But you have the quantitative speed of light. I mean, and we're like that thing is going, faster and faster every day. Every
So
day.
what they
It's
did
measured.
is they put, if you looked at it, you'll see that they put lots of gold on it. It's all coated in gold sheets, okay? And the reason they use gold is because it's the best shielding for radiation. And so and before they sent it up, they did these experiments where they like took this stuff and put it in a nuclear reactor to make sure it could withstand that kind of radiation. You follow? That's part of the testing that they have to do on all these spacecraft before they can put them up. So I'm pretty sure that they made sure that it was going to be hardened enough so that it would survive as long as the power was on.
Wouldn't it be like layers being shedded off as the constant of rays bombarding it? Like it would, eventually chip away at it until it becomes
Maybe
something
in a
else.
few million years down the road, but not in our lifetime. No, I think that stuff would have went, if it was going to break, it would have broke a long time ago.
It's not about breaking, it's about transitioning. Not as much as breaking, but as like element transition.
Yeah, if it was changing the elements in the thing, I would think that the electronics in it would stop working, not.
No, it would just be like an upgrade. Everything is relative to its surrounding.
Yep. It depends on how you package it.